Hey everybody, in this tutorial we're going to apply a damage flash to things in our level that can take damage. This is pretty common in games and it lets the player know that something took damage and something important happened. So we're going to set this up in a very modular way that we can reuse in future projects and we can customize it on an object by object basis. So let me show you what that looks like. Okay, so let me show you the setup that we're going to build towards before we actually build it. If I hit play, this is the FPS controller. Now you could apply damage in any other game type as well, but I just want to show you a simple way to test this. We have our gun. We can shoot a cube and you see it flashes a white material whenever it takes damage. And this one flashes a different color material. We can actually customize this, all right? And so the way that we would customize this is we're going to build an actor component called hit flash, which will allow us to change the flash color. It'll allow us to, make it stronger or not as strong. How much emissive do we want? And we can even change the amount of time to flash it on a per object basis. And the nice thing about this is that if we wanted to add a hit flash to a new object, all we need to do is then apply the hit flash component, which will then talk to the material and flash the emissive. We're going to use an approach where we use a material, which let me show you. We have a material over here. We're going to set up an emissive and then control the emissive amount at runtime, meaning that one limitation of this setup is that we need to set up our material to receive an emissive color parameter as well as an emissive multiplier, and then we're just going to turn this on and off at runtime and control the flash that way. There are a lot of other ways to do flashes, including stencils. I've seen other methods. But I think this is, to me, the most simple and pretty reusable and modular system that I wanted for my project, so I just wanted to share it with you all. Okay, so I'm inside of a new first-person controller project. I do have the starter content, and this will give me the level prototyping folder, which the nice thing about that is it gives me a material that I can use as a starting point. It's not very complicated. But what I need to do is I need to add emissive to my solid material. So I'm going to duplicate this. Normally in a project, you would have a master material that has a lot of features in it. In this case, just to keep things separate for future tutorials, I'm going to duplicate it out and then call this m_simple for now. But later on, you could add functionality with other tutorials. So I'm going to take this simple material and I'm going to save it first. And once that's done, I'm going to move it into a separate folder. I'm going to make a new one at the top. Let's call it _game, just so I can keep my thing separate from what is provided. So m_simple, make sure you have the right one, and then move it. So move here. Okay, so this will just allow us to isolate all the assets that we're changing because I don't want to mess with the other first-person character stuff. I don't want to throw off your other tutorials that you might be doing. So inside of this material, if I double-click to open it up, we want to add the ability to control the emissive, which is what allows a material to glow. Because when we take damage, we want the thing with this material on it to glow for a brief amount of time and then stop glowing. So in order to do that, we need to control the emissive. What I'm going to do is I'm going to create something called a parameter. So a parameter is kind of like a public variable, if you think about it that way, for materials that we can then control in other places. So outside of this material, I want to talk to the material and tell the emissive to be a certain color or to be a certain multiplier. So that's what I'm going to set up here. So I'm going to make something called a vector parameter. The hotkey for this is just if you hold down V and you click, V as in Victor, you can see it's trying to name it something crazy. So I'm going to change this name over here to capital E emissive color. Now, we're going to call this through blueprints. So this name is actually very important and you need to get it exactly correct. So whatever you name it, I recommend this. It should be very specific. So just keep that in mind. Now, we could just plug the color directly into the emissive color, but the problem is we want to control how intense it is so that we can modify that over time. It's not enough to just change the color. If it's 0 intensity, it's really not going to matter what the color is. So I need a value to multiply with the color to get a resulting amount. So my value is just going to be a number, kind of like over here. We can actually copy this and paste any one of these two. So this is another parameter, but this one just takes a single value. You could also right click and find it and create it yourself. But I'm going to rename this one emissive multiplier. Okay, and so what I want to do is multiply the color by an amount. In this case, it'll be 0 to 1. You could go more than 1 if you want, but we don't need to. So I'm going to type multiply. Okay, I'm just going to multiply my color by my amount. And I'm going to plug this resulting amount into the emissive color. So we'll take the color, we'll multiply it by an amount, and I'm actually going to turn my emissive down to 0 by default. We can leave that off by default as well. I think that's fine. So I'm going to save it. Okay, but just to show you what would happen if I were to turn this on, if, first you have to turn on the alpha, and then you turn the white all the way up, right? Hit OK. See how it's white, but we're multiplying by 0. If we were to change this to 1, you see how now our material is multiplying. So I'm going to turn that back, but this is the effect that we want at runtime. So I'm going to turn this back down to 0 because any other materials I make, I probably don't want emissive. For the most part, I don't want that. Yeah, I mean, the alpha is 0, but we can turn it down to black too if you like. All right, so I'm going to save it and close. Now, here's the important thing when it comes to materials. We actually don't want to apply a material to the things in our level. We want a material instance of our material, which is just like a more pared down, more optimized instance of the material. So the things in our level might have different colors based off this material, but we don't want to just directly apply this material. So we're going to do something called a material instance. So if I right click my material and I say create material instance, like that, I'm going to say mi underscore and then call it whatever this material is going to be. So in this case, I'm going to make a shootable block. So we'll just say shootable block. Any other scene, it could be crate, wall, enemy, whatever your material is. So if you double click and you open this up, you see how this is not the material instructions. This is just a visualization with all the parameters that we created. So you remember we created this emissive color and we created this emissive multiplier. I see since I duplicated this, it changed the category over here. Let me show you if you want to change that. If I just go back into my msimple material, if I click my emissive multiplier over here under material expression, the surface properties, we can put it into a group. So let's say if I wanted an emissive group, I'm going to type something new here. I'm just going to say emissive, right? And then I'm going to go to my emissive color and I'm going to put that in the emissive group as well. So once I save this, all this is doing is this is putting it into a group over here, like a grouping name. Not really required, just kind of nice. So for my shootable block, I actually don't need to mess with these things right here, but I may want to change the color of my object, right? Like if you have a different texture map that you're applying, you'd have to add additional things in your material. So remember, your materials are going to get very complex. As long as you add the emissive color and the emissive multiplier, that's all you really need to do to make this tutorial work. So for now, I'm just going to apply let's do like a light blue, something like that. So I'm going to save and back out. But the important part is that you actually have the ability to use emissive color and emissive multiplier. So once we have our material instance, I'm going to, let's create a new actor actually that we can use this for. I don't want to, reuse this box over here. I'm going to create a new actor, and this is going to be our shootable block. So choose actor, BP underscore shootable block. Okay, double click to open that up. Now inside of the shootable block, I'm going to make a static mesh because I do want it to have a mesh visual. Cube is fine. And if you want the mesh to be the main root of it, you can always just drag and drop that and create that root. Doesn't really matter. It's just nice to get one additional thing out of the way. Now for our material, for our shootable cube, we're going to assign the material instance that we just made. Remember, this is our shootable block, so mi underscore shootable block. This is the material instance that we created from that material earlier. So we can always change this color later if we want. Hit compile, save. The important part is that if I drag my block into the scene like that this is something that I can shoot. Now, if I hit play, right, you're going to see that it's hovering. So if you did want that to have physics, you could come back into the blueprint actor and you could just go to the static mesh right here. And then you come down to simulate physics. Doesn't really matter, right? You may want shootable blocks that don't fall. All right, so let's say that we want that. Okay, so we have our blueprint block, and we have our material instance that has the capability of emissive that we can control. So this is our setup, and then we just need to add the functionality for controlling the emissive. So before we get too much further, let's just apply damage using our projectile in the first-person shooter. Now you can apply damage any way that is appropriate to your game, but I'm just going to show you the easy way to do it inside of the first-person shooter setup, because if I pick up my weapon and I start shooting, what I really want to happen is I want my projectile, when it hits another object, to apply damage, right? Oh man, that'll be crazy. I may actually turn off the physics on that just so we can see it more easily, but we'll see. So in order to do that, I need to find my projectile, whichever one I'm using in this game. Again, for you, how you apply damage just totally depends on your game type. But for the first person template, if you go down to first person, at least for now, maybe they change it, go into blueprints and you'll find the blueprint underscore first person projectile. If I open that up, what this is doing is when there is a hit event, like some collision with the projectile, we are doing things, we are simulating physics, and we are adding an impulse, which makes things burst outwards when they're hit with the projectile. So what I want to do, just very simply, is drag off of event hit and type in apply damage. Okay, and make sure that you connect this back to the node after so that we're not stopping here. It's not very organized, but that's fine. And the last thing we need to do here to make this work is when we do our event hit, we actually need to damage the other actor. So we're on the projectile, meaning that the other actor, the thing that this projectile hit, needs to be damaged. So we drag off of other, plug that into damaged actor, and so now we will apply damage to the other actor, and it should receive some. You can put in a base damage here if you want. I'm just going to put 1, just so it receives something, but it shouldn't really matter for our setup. Compile, save, come back in. Right, we're applying damage, but it's not really obvious at all. I'm actually going to go and turn off that crazy simulation physics. So let's go back here. I decided I didn't want it. That's fine. That happens. So I'm going to go down to our static mesh component over here, and I'm going to turn off simulate physics. So this is more proper to like a breakable wall or something. You can always turn on the physics later. So now when we're thinking about our functionality for a hit flash, we need to think if this should belong to the cube or if it should be something generic that we can apply to other things. So for example, if I were to add the logic in here inside a BP underscore shootable block, then anytime I wanted something else to hit flash, I would need to copy that code and put it in the other blueprint as well. What makes more sense to me is we're going to define a component that we can add to any object we want and then have all the functionality inside of that component so that we can attach it to different objects, right? We could have a wall that hit flashes or an enemy or a crate or whatever. And we're going to do that with something called an actor component. So if I close out, I'm going to create a new blueprint, right click, blueprint, and this will be called an actor component right here. It looks like a little puzzle piece. So this is BP underscore damage flash. So when this thing receives damage, it will flash a material, assuming that we have the correct material applied. So I'm going to save this, save selected. We'll open it up. Now, the interesting thing about an actor component is it cannot assume things about the overall blueprint that we attach it to, meaning that if we want something, we need to search for it by getting the owner and then looking at things on the actor. Meaning that it's really hard to pull outside things into this, but we do have a couple options, but we can't really do the drag and drop thing that we could in the other blueprints. So let me show you how that works. If I open up the shootable block, you see over here, we can get these components by just dragging and dropping into our event graph right here. I'm gonna delete that. We can't really do that with the component because we don't know what this is attached to. One thing we can do though, is we can get access to the blueprint actor right here by searching for the owner, meaning that this blueprint actor is the owner of the component that we attach it to. So I can get access to the shootable block by running something called, so right click over here inside of damage flash, called get owner. Stop one. And this will return the owning actor of this component that we attached it to, meaning that it'll give us a shootable block. And so once we get this, it's usually good practice to save this off and hold on to it and then reference. So we'd call that caching. So I'm going to right click this return value. So we get the owner and say promote to variable. And so we can call this variable owner. And so now anytime we can drag the owner in, we can reference it, right? Get owner and do something from it because we've already searched and gotten it and saved it. So let's do this on begin play. Okay. Get this out of the way. I don't even think we need event tick. Okay, so on begin play, we're going to search, we're going to get the owner of this component and then save it off. We don't really need that to be public because it's not going to change. Now, the other thing that we need to happen, and this part's going to be kind of weird, is we need to respond to an apply damage event. Now, to do that, we're going to bind a new event to the on take damage event and then respond to it by flashing. Now, that may sound weird, but the code for that is drag off and type bind event on take any damage. Okay. All this is doing is essentially watching this event so that we can respond to it. Now our response is going to be this event right here, this red box. If you drag off of that and say create event, enter. If you dragged off and type that in, then it will create an event that we can use to respond to the on take any damage event. So we actually need our parameters to match. So on take any damage will give us like how much damage, damage type, and a lot of other things. So we need the event that we respond with to be the exact same in order for this to work properly. So I'm going to create an event, click the select function, and say create a matching event right there. Okay, so once we do this, and I call it damage flash, like that. Once we do this, and we connect our execution node, when we bind to the event, we created this new event called damage flash that has the same exact parameters, meaning that when the on take any damage event is triggered, we will run our damage flash because we bound to it. So this is very handy because we can apply damage to this object that this damage flash component is attached to, right? Like when we shot the cube, our projectile was applying damage to the things that it hit. So our cube is going to receive the damage event, and then because we're binding to this on take any damage event, we can respond with the flash. Kind of weird to talk through, but hopefully that makes a little bit of sense. So we're going to actually do this later, but we could actually print out if you want, print string hit flash, compile save, just to make sure this is working. If I come back into my shootable block though, we still have not attached the component to give it the behavior. So this is our behavior, but we still need to say this shootable block needs the behavior to hit flash. So I'm going to go to my shootable block blueprint, add component, and we're going to look for BP underscore damage flash. Perfect. And we'll keep that the same. All we really want to do is test to make sure that this print string is happening, this hit flash, before we keep going. So compile save, make sure you compile save both of those. Your shootable block should have a BP underscore damage flash component attached, all saved up. Minimize, hit play, right? Hit flash right there. Meaning that if we go back to our game, open up, we're actually getting this far in the code, which is perfect because now we can add our functionality to actually do our damage flash. So there's actually going to be two steps to doing this. The first step is we need to create a dynamic material instance from our material so that we can change it during gameplay. But the other thing we need to do is actually set the values on our emissive once we have our dynamic material. So let's set that up first. First, let's think about what we need to do. We need to look at our owner from our component, look at our owner, find our static mesh, and then create a dynamic material out of whatever is on the mesh, like whatever material is on the mesh. So we're going to actually access the owner, which remember we already found and saved. So I'm going to drag that over here, get the owner, and from the owner, we're going to get component by class. And this will allow us to look for a component that is on the owner, so other components, kind of like a get component if we were inside of Unity. So we have our owner. We want to look for the component class of static mesh. So our static mesh component. Now, if you had multiple materials, you could do something here where you could search through multiple static meshes. That's a little bit more complex. I'm just going to show you the easy version of this. So we're going to take our get component by class. We're going to return, and we're going to run a node called create dynamic material instance. Okay, so this will allow us to modify this instance at runtime and also not change the other versions of our shootable block and just this specific material instance. So we're going to connect that in. And another thing I think we should do, which is just good practice, is when we're doing our search, we want to make sure that it's valid before we actually try to do anything with it. So I'm going to pull off of my get component by class the result of the component that we found, and I'm going to type is valid. Okay, so this is our is valid node. We're going to run it. We're going to do our check. It's kind of like a null check, among other things. And we're going to say, if it is valid, then we're going to create the dynamic material instance. If not, then we don't want to do anything. We may not even have a static mesh attached to whatever we put this component on. So we're going to do that check there. And then the result of our dynamic material instance that we create, we're going to promote that to variable so that we can save it and then access it later. So let's rename this Flash Mat. Okay, so this is the material that we created, the dynamic one in our scene that we're going to flash anytime we take damage. So let's add a comment here too. Let's highlight this. Hit C. We'll call this setup dynamic material instance from actor. Compile, save. Okay, so now that we have this set up, we actually need to change the values on the material instance that we set up. So just as a reminder, our material instance, we exposed the emissive color and the emissive multiplier. We are going to set them by looking for the name on the material instance of emissive color and emissive multiplier, and we're just going to change these values in blueprints. So this is important. Whenever I type this name in, you need to get this exactly correct, and the object that you apply this to has to have a material instance with the emissive color, emissive multiplier attached, just like we did before. So make sure that that's the case. Compile, save. When we receive our damage flash, which we know is happening because we tested it with the print string, we are going to get access to our flash mat over here. Remember, this is the dynamic material that we saved. We can get access to that, pull off, and say set vector parameter value, that middle one right there. So what this allows us to do is look for a parameter by name, and we're going to look for emissive color, and then set the value to something new. So we'll plug in that execution node. The question is, what do we want to set the value to? Right now, this is setting the value to black. I think I may want the designer to control this on an object by object basis, meaning that I probably want this to be a variable, not hard set inside of blueprints. So I'm going to right click, promote to variable, and this is going to be a type of linear color, which it should create automatically. And we're just going to call this flash color. When we damage flash, we're going to set the flash color to, and then whatever this is set to. So let's add our default value over here. I'm going to compile and save so that we can see our default value. And I think by default, I want it to flash white. So first thing, I'm going to turn the alpha all the way up. I'm going to turn the white all the way up and hit OK. Now, the other thing is because we are searching for a parameter name, right now, there's nothing in there, so it's not going to find anything. We need to make sure that this parameter name is the exact same. This emissive color, same spelling, same everything. So triple check your typing here, but I'm going to type in mine, which is emissive color with a capital E, capital C, just like that. If it doesn't work, you just need to double check your spelling. Search for this parameter name and then change the values of that parameter to our new flash color. So swap that in using our dynamic material. Once we do that, we're actually still not going to see anything because our multiplier will still be 0. So we need to do the same thing, but with our multiplier. So for this one, we want, again, to pull off our flash mat. I'm just going to pull off here since it's so close. We're going to call this one set scalar parameter value. So in the case of a number value, that's going to be a scalar value, whereas a vector is our color. So we're going to connect that right there. Our value, I could put in 1 here, but I also might want the designer to be able to control that as well. So I'm going to promote this to a variable. So right click, promote to variable. I'm going to call this flash intensity. And we'll pull that down here. Compile, save, and I'm going to set the flash intensity default value to 1. And again, we need a parameter name, and this needs to perfectly match what is in your material instance for emissive multiplier. For me, that is capital E emissive multiplier. Triple check your spellings. Compile, save. Now we know that we're getting this far. This is going to change the emissive and the multiplier for our dynamic material instance, but it's not going to change it back. So as long as we shoot the thing and it changes to a color, that's all we need for now. So let's test this out. Save here, hit play, pick up our weapon. Okay, cool. So we're changing it when it receives damage, but it's not changing back. That's what we need to do now. So to undo our flash, we're going to do what we just did, but in reverse. So the first thing is we're going to pull off our set values here, and we're going to type in delay. We want to wait for some amount of time. And the question is, what is that amount of time? I would say it's up to the designer. So again, we're going to promote the duration to a variable. And this is going to be called flash duration. I'm going to pull this down here. I'm going to compile, save. And I think I want our default to be 0.1. I think that's a pretty good flash amount. Maybe we want this to change on an object by object basis. We are allowing the designer to do that. So we can compile, save. Now, once we wait the flash duration, we need to return the emissive back to its original value and turn down our multiplier. So what I'm going to do is I'm going to copy these two nodes here, since we already went through the work of building them, and paste them over here. And we're just going to undo what we did before. So when our delay completes, we're going to, again, set the emissive color, but this time we're just going to keep it black. And this time we're going to have the flash intensity be 0. Default black value, 0. Make sure that your flash matte is still plugged in though. We still need that. Your emissive name for color should still be the same with the emissive multiplier, whatever that is. I'm going to put a comment around this and say return to original values. Now, some of you might already be noticing a bug, which we'll get to in a second, because we don't necessarily know that these are the original values, but for now, it'll help us test it. Now, I think while I'm at it, I'm going to pull a comment around this and say set flash values, compile, save, minimize. Let's test it out. So after 0.1 seconds, it should return. Okay, so that's working, but there's something that's bothering me here. And that is if I go back into my blueprint, we are hard coding the values of what the original was. We don't know that this wasn't already kind of emissive, or that it didn't have some partial emission or some intensity that the artists worked a long time on, right? So we actually need to save what the original values were and then return to what we saved, not just hard code in black and 0. Not all of these objects will have 0 emissive. Some might have some emissive, and we want to return to the original values, not a hard-coded nothing value. So here's what we need to do. Up at the top in begin play, when we create our event, we create our dynamic material instance, we also want to save the current values of the material instance parameters. So we're going to eventually change the emissive color and the emissive intensity, save the starting values of those up top so that we know what to return to. So to do this, I'm going to get access to my flash matte right here. Right, we could just pull off this, but this will be cleaner so that we can separate it out later if we want. Just like how we can set a parameter value, we can actually get a parameter value as well. So we're going to pull off, we're going to get vector parameter value. Okay. And we need to give it the correct name, so I can copy paste this right here. I probably might want to move this into a variable if I'm reusing it that many times, but whatever you need for your project. I'm going to compile, save, and we're going to connect the execution pin. Now here's the thing, we're getting the starting value of our emissive color, but we need to save it. So I'm going to save this return value by right-clicking, promote the variable, and we're going to call this init emissive color. So we're going to save the starting emissive color before we change anything. We're going to store that down in a variable, and we need to do the same thing for our emissive intensity. So we're again going to pull off of flash matte, say get scalar parameter value, connect that in, and right here, our parameter name, let's copy that as well, emissive multiplier. Also, make sure that you don't mix up these nodes. Like if you're looking for the vector, you need the emissive color. If you're looking for the scalar, you need the multiplier. Make sure that you're using the correct nodes for the correct parameter names. And we have our emissive multiplier. We get that starting multiplier value, and we want to save that as well. So right-click the return value, promote the variable, call this init emissive multiplier. Compile, save. Okay, so once we save off the initial values of these, when we return, we need to plug in the initial values, not whatever the default here, like 0 and black. We want to return to what we started with. So I'm going to pull off the init emissive color, get emissive color, and plug that in so that when we return to the original values, we're returning to the initial emissive color. I'm going to do the same thing with the emissive multiplier, the initial, get it, and return to the initial emissive multiplier. I think this will work. Let's put a comment around this. I'll say comment get initial emissive values, but we're not breaking anything. Compile, save. We can test it out real quick if we want. Okay, cool. Now, the nice thing about this is if we come over here and we were to add an initial emissive, we could make it, I don't know, kind of blue, glowy, put the emissive multiplier at 0.5 or something, right? Like if we did have a material with some kind of emissive on it, we're still returning to the original. So that's kind of nice and kind of proofs it a little bit, but I'm going to take these out, put it back. Okay, uncheck those, save, and it should all be working. But if we really want this to be modular, we still need to clean up a little bit. So what I'm going to do is I'm going to group some of my variables, make sure that nothing is exposed that doesn't need to be, and then we're going to try and make another version of the cube to make sure that we can get varying behaviors between them and that everything is modular like we want it. So I'm going to come over to my variables. I'm just going to reorganize a little bit. Let's make a category. We'll call this on the owner variable. We'll call this initialization or something. Initialization. And everything that we're saving and holding on to, we're going to put inside of this category. So in other words, our flash mat, we need to compile, save. Then we select our flash mat and then we choose the category initialization. We'll do that for init emissive color. So init emissive multiplier, put that inside of the initialization category as well. Okay, so all of these are the initialized variables that we're holding on to. We're also going to make an emissive category for everything that the designer will want to control. So let's make another category over here. Select flash color, go to category, and type in flash settings. Okay, and that'll assign that one. Compile, save, go to flash intensity, put that one in there. Flash settings. Flash duration, compile, save. You can also do other things like you can, make sliders or clamp the values if you want. It's totally up to you at this point. But I also want to expose the variables that the designer will want to control. So for example, I do want them to choose a different flash color if they want. I do want them to choose an intensity and a duration. So I'm going to check the eyeball for all of these right there. Hit compile, hit save. And what that means is that if I come back over to my shootable block and I click on the damage flash component, you see now I have my flash settings over here and I can actually change these. If I want the flash color to be, red, that would be nice. I can change that. My default is good. So my flash intensity default is 1, that's good, 0.1. But I change this color to red. So if I hit save and I come back over here, come to my scene and hit play, if I shoot the block, it should turn red. Okay, so now let's test this. If I were to click the block, hold Alt, make a duplicate. If I hit play, I should only be able to shoot one block and the other should not flash. Okay, cool. Okay, and so that is our dynamic material instance that is working so that we are changing this one instance of the material rather than everything with the material instance shootable block. And so now all shootable blocks will have, if I go into it, a red flash color, which is nice, and it's what I want in this case. So the very last thing I'm going to do is I'm going to test the modularity and make sure that I can put this on something new and that it still has the intended functionality. So let's make another blueprint class. We'll just make this an actor, call this BP shootable sphere. Okay, we're gonna double click. Come in here, let's add static mesh, say sphere, okay. We'll make this a root. You don't really have to, but you can make this a root, compile, save. We are still applying damage to it. We still need the material instance, right? Like if I were to hit X and pull this into the scene, we can apply damage to it, but we still need a material instance for shootable block. So let's actually make another material instance off of our our M simple with our emissive that we set up, we need a different material instance, not the shootable block. We want this one to have a different color, for example. So right click on the M underscore simple, create material instance, MI underscore shootable sphere. Again, this could be an enemy material, whatever other materials you want. I'm going to save all. I think I have a couple floating things there that need saving. Open up material instance. Now for this one, base color, let's make this green. All right, that's pretty good. Make this green. No default emissive. Actually, let's do a default emissive just to test that out just a little bit. We'll do a slight emissive. I don't know, 0.3. Okay, so we're slightly emissive there. That's fine. I'm really just testing my system here. Close it. And I want my shootable sphere to have this material on it. But we need to actually put that inside of the blueprint. So let's open up our blueprint shootable sphere. For here, we want our materials to be mi underscore shootable sphere. Perfect. Okay, compile, save. Look in the viewport, make sure it looks how we want. Now remember that even though we have our material instance that can flash, we still need our actor component for our flashable behavior. So we'll do add BP underscore damage flash. Okay, and then when we click the component, we can customize this to be whatever we want. So, we're not going to mess with initialization, but for our flash settings, let's say we do want to flash at white, one at 1.1. I think all the defaults are fine. Compile, save. Hit play, test it out. Okay, so you can see how quickly we can add a damage flash onto new objects. Just to recap, all we did is we created our new object. We created another material instance that is using our emissive color parameters. Again, you might have a large master material that this is set up through that you can control. So we created our new material instance, attach that to our new object, and then we went into our new object and attached the damage flash actor component that we created. So hopefully this shows you how modular the system can be and how you can start to create actor components that can reuse behavior.